El Niño is one phase of the El Niño Southern Oscillation (ENSO) climate pattern, which involves interactions between the atmosphere and the ocean in the tropical Pacific. The Southern Oscillation refers to changes in atmospheric pressure patterns between the eastern and western Pacific regions. El Niño events are not regular. They typically occur every 2 to 7 years and can last for several months to a year or more. The strength and duration of El Niño events can vary, with some being relatively weak and short-lived, while others are more intense and long-lasting. The name El Niño comes from Spanish, meaning the little boy, or the Christ child. It was originally used by Peruvian fishermen to describe the appearance of unusually warm ocean waters near the coast of South America around Christmas time. El Niño can have far-reaching impacts on weather and climate around the world. These effects are not limited to the Pacific region but can be felt in many parts of the globe due to the interconnectedness of the Earth's climate system. During El Niño, the warmer-than-average sea surface temperatures in the central and eastern Pacific Ocean affect the position and intensity of the jet streams, which are fast-flowing air currents in the upper atmosphere. This, in turn, influences the path of storms and weather systems. In some regions, El Niño can lead to heavy rainfall, flooding, and landslides. This is particularly notable in parts of South America, including Peru and Ecuador. Conversely, drought conditions may occur in Australia, Indonesia, and some parts of Africa and Asia. El Niño tends to suppress hurricane activity in the Atlantic basin but can increase the likelihood of tropical cyclones in the Pacific region. While El Niño can bring beneficial rains to some areas, it can also lead to destructive weather events, economic losses, and disruptions to ecosystems and agriculture. After an El Niño event, the climate often transitions into a LaNiña phase, characterized by cooler-than-average sea surface temperatures in the central and eastern Pacific. LaNiña has its own set of impacts on weather and climate, which can be different from those of El Niño. Some common impacts of El Niño include 1. Changes in precipitation. El Niño can cause shifts in rainfall patterns, leading to heavy rains and flooding in some regions and drought conditions in others. For example, it can bring increased rainfall to parts of South America, while leading to drier conditions in Australia and Indonesia. 2. Temperature anomalies. El Niño can lead to higher-than-average temperatures in various parts of the world, affecting both land and ocean temperatures. 3. Hurricane suppression. El Niño tends to suppress hurricane activity in the Atlantic basin, reducing the number of storms that develop. 4. Wildfires and heatwaves. Some regions may experience an increased risk of wildfires and heatwaves during El Niño events, particularly in areas affected by drought conditions. 5. Fisheries impact. El Niño can cause changes in ocean currents, affecting marine ecosystems and disrupting fish populations, which can have implications for fisheries. Conversely, there is also a counterpart to El Niño called LaNiña, which is characterized by cooler-than-average sea surface temperatures in the central and eastern Pacific. LaNiña events have their own set of impacts on weather and climate patterns and often result in opposite conditions compared to El Niño. El Niño and LaNiña are natural climate variations that occur irregularly, and their effects can vary from event to event. Climate scientists monitor these phenomena closely to better understand their behavior and to improve climate forecasting and predictions, helping to mitigate the potential impacts on societies and ecosystems around the world. El Niño and its cooler counterpart LaNiña are part of a natural cycle between warming and cooling of the Pacific Ocean that was first detected by South American fishermen in the 17th century. That said, climate change is interacting with this cycle and shaping a future with stronger El Niño episodes. Before global warming, the world's temperature would reset after El Niño, but now it remains elevated. The combination of human-caused global warming and short-term warming from El Niño could mean that the second half of 2023 or early 2024 will break global temperature records. Brad Rippey, a meteorologist for the U.S. Department of Agriculture, says El Niño is expected to cause flooding in some regions and droughts in others. During the Northern Hemisphere summer, June to August, El Niño will likely suppress Atlantic hurricanes and bring drought in regions such as Central America, the Caribbean Basin, and southern and southeastern Asia. During the Southern Hemisphere summer, December to February, areas like Southern Africa, Australia, and the Western Pacific Basin will experience more heat, droughts, and fires. Some regions of the world, however, will face wetter conditions. Parts of South America, such as Argentina, have been reeling from drought because of the long-running LaNiña that began in 2020. With ElNiño, these areas would finally get doused with precipitation. Climate scientists use a variety of tools to predict when and how hard ElNiño will hit. Some examples include satellites to track wind and tropical rainfall patterns, ocean buoys to monitor sea surface temperatures, and mini radios strapped to weather balloons that measure air temperature, humidity, and pressure. Overall, ElNiño is a natural climate variation that plays a crucial role in influencing weather patterns and climate around the world. Understanding its behavior and impacts is essential for climate scientists and meteorologists to improve forecasting and preparedness for potential extreme events and mitigate their effects on communities and environments. Thanks for watching.